Good morning, class. We are about to embark upon an experiment that is going to allow us to calculate the initial velocity of a projectile emanating from a mini launcher. Okay? So let me just give you guys some pictures, some ideas of what we're going to be doing. I'm going to start off with the first one. That's this one. So we're going to bring a video into video physics, but right now these are just pictures and paper, 553. This particular item here is our mini launcher, okay? And that's the main thing you need to know when it comes to that. And we have a projectile emanating from this mini launcher. We want to calculate the initial velocity at this location, okay? So we're going to use some techniques, some scientific techniques to actually do that. We're going to use an initial position here, and we're going to use a final position. So we can get our displacements in the X, okay, as well as the Y. So let me go in on this a little bit. Let me see if I can just slide to the left a little bit. You'll see if you get closer here, we have this white piece. This is our launch position, and this is where we're going to set our points. So this is our launch position or our initial position. Often we'll refer to this as X naught, Y naught, V naught, T naught. All of those things mean this kind of the same thing. At this position, you have the initial position in X and Y. You have the initial time, the initial velocity. Even if you had acceleration that was changing, we can do it that way. So let's just keep going on. The ball is going to land at some final position. We want it at the first bounce. It's basically what's happening here. So you'll see that we have ourselves a nice little V here. So I'm typically expecting it to strike the table right here. Okay. When I say right here, I mean at this location. So where that V is located, and so that's pretty much the gambit of the experiment. The main idea, we're going to be taking points between the initial position and the final position. Now, we need to set the origin and scale. So let's talk about the origin and scale. You'll see that we have our origin set right here, and I am acting as though I don't have a pen that I can write with, but we have our origin set at this location right here, okay? And what that allows us to do is to define our 0, 0 position. And we've also calibrated this particular experiment using our pixel rod, and our pixel rod happens to be 193 pixels. And we have decided to use, again, 0.1 meters, or a tenth of a meter. So let me just slide this over. You can see it a little bit better here. Again, here's our origin. Now, I've been using my origin, or I've been setting the origin right below the firing position. I might change that. I might set it up here, like right in the center. And why am I doing that? Because the primary thing that we could see is when the ball is launched out like this, we actually can't see the bottom of the ball. So I typically would do this thinking old school, like we're actually doing this experiment by hand. And so you could see where the ball is going to land. It's going to land on the table. But what we can clearly see is the streak in the ball. And let me just show you before I go into talk about our calibration again. Let me go back and let me show you what I'm talking about. You see, look at this. So you see this streak here. This is our ball. This is the light that's emanating, and it's like it's in the center here, okay? As opposed to the bottom here where that's what I'm choosing. Now look at the error that could potentially be produced. If I go here, I have to guess where the ball is striking down here. I have to guess if it's, I don't know if it's here, but I can make a fairly decent guess by landing on the streak here, the reflection from the ball. So that's why I would want it. I'm going to suggest that we change. And when I do this experiment for you guys, I'm going to change that. But in the past, I've been doing that. But now it's starting to introduce error. So that's pretty much the idea behind the experiment. And again, here's our pixel rod. You'll see that we're going between 80 and 90. And this pixel rod happens to be 10 centimeters. So again, we have our representation there. I'm just being redundant, or I'm reiterating that.